Hi, Accelerated Algebra. So this video is to check your answers and make corrections. If you need to pause it at any time to make a correction to one of your problems, make sure you do that. The biggest thing to look out for here on number 1 is to be sure that you realize that when this negative sign is in front of this fraction, it means that applies to the entire fraction. So this whole numerator should be multiplied by -1. You might have not multiplied both sides by 6. That's what I did first. But either way, make sure that you check for that. The other thing is that when you divide both sides by a negative with an inequality, you have to remember to swap the inequality sign. So be sure you did that. And my final answer was x is greater than or equal to 8/3. So I drew that on the number line like this and have it a filled in circle. For this one, I went ahead and multiplied both sides by 2. I don't have to swap the inequality sign because I'm multiplying by a positive. And then I just went ahead and solved. Be careful with the distributing, right? And I got x is less than 8/9. So I ended up with x over on this side. So this technically says 8/9 is greater than x, but that's the same thing as x is a less than 8/9. Remember, the alligator eats the bigger part. So it should be an open circle, and your graph looks something like that. All right, this one's just a tiny bit trickier. Think of all the numbers whose squares are less than 4. So x squared is less than 4. So like 1 squared is 1. That's less than 4. 1.5 squared is going to be less than 2 squared. And 2 squared is 4. So anything right up to 2 is going to be good. But then also we have the negative numbers, right? -1 times -1 is +1. So -1 squared works. And anything right up to, but not quite at, -2 works. So here's my graph. It's the numbers in between. So you might have written this as a compound inequality. -2 is less than x is less than 2. Or you could have written it in this way. X is greater than -2 and x is less than 2. Either way that you wrote it is fine. Okay, this one, I rewrote the equation in regular old slope-intercept form with the -10x first, just so I could realize that that's the slope. So the slope is -10, and something's decreasing whenever we have a negative slope. What's decreasing here is his distance from home. So his distance from home decreases at 10 miles an hour. And then the y-intercept, of course, is 5. So if he's going from school to home, that school must be 5 miles from his house. So he starts 5 miles from home. Now, this point, right, 0.5 is the x-coordinate. And remember, that means time in hours. So half an hour for something. And then the y-coordinate is 0. So that means the distance from home is 0 at half an hour. So it must take him half an hour to get all the way home. All right, so this next problem is a lot like some that you practiced on Delta Math. Ori's got this equation, y equals 20x, and that's how much she is saving, right? So I can see, like, if y is the total savings and x is the number of weeks, she's saving $20 a week. Here for Eloise, she's got this graph, so you can see I drew on it and calculated a slope. Be really careful with this scale, because you might want to say that it's maybe like 3/2, but really, when we are going up 30 and over 2, that's a slope of 15. So, Eloise's graph has a slope of 15, so Ori must be saving $5 more each week. And my work is kind of shown over here. All right, now we know that Ori's relationship here is proportional because it's just y equals kx. It's in that form. Eloise's is not. If we were going to write her equation of a line, it would have a +10, right? And so that's not proportional. Here on the problem with the plant, I went and calculated all of the change in y divided by change in x, or change in h divided by change in w, and it all reduces to 1.5. So that's the constant rate of change, and that's how I know it's linear. And then I've kind of done the work for part B, which is 1.5 is the slope, and of course that means that the height is increasing 1.5 each week. So it grows 1.5 centimeters each week. You might have done this next problem a little bit different, but I just wanted to show you a way that you could do it, just kind of using this thinking from the table. So 210 was a point in the table, right? 210. And then I just use the slope to kind of go backwards. Every time I go down 1 for the x or the w, I must go down 1.5 for the height. So at 1 week, it must have been 8.5 centimeters tall. And at 0 weeks, it must have been 7 centimeters tall. So that must have been the starting height. You might have done it by, writing out the whole equation and solving for the b, and that's totally fine too. For this equation, finding the x and y intercepts, you just have to remember for the x-intercept, you plug in y equals 0, and for the y-intercept, you plug in x equals 0, and then you get 2 different points, and those get plotted in, then you can draw the line. So each of these should graph pretty simply, and drawing on my screen it was a little bit messy. Just remember that x equals -3. That's a vertical line here. All the x coordinates on this line are -3. Right here is -3, 0. Here's -3, 5. All the points on this line have an x coordinate of -3. Likewise, for D, all the y coordinates are 2, right? And the slope is 0. This one has an undefined slope. For B, that's just a straightforward slope-intercept. And then this one, let's talk about just a little bit. This is point-slope form. So point-slope form looks like this. And we'll talk about in class, hopefully we already have, about how this comes straight from the slope formula. So this is the same as minus -1 here, and this is the same as minus -3. So I can see that the point from this equation is actually this point, -1, -3. And that the slope is this number right here, the -1/2. Now, if you didn't see that, you might have said, oh, I'm just going to convert this equation over to slope-intercept form, and that's fine. So I can just distribute that 1/2 and then solve for the y. So in slope-intercept form, we get y equals -1/2 minus 3.5. So let's just go back and look at that graph again. So you can see it's crossing here at -3.5 on the y-axis, and you can tell that the slope is down 1 over 2, or likewise down 1/2 over 1. Remember, when I say over, I'm always going over to the right. Okay, so let's talk about some of these problem-solving ones. Okay, here's number 9, and I should say that I've done this problem, I think, at least 3 different ways now, so you might have done it a totally different way. As long as you get the same answer, and you've done something mathematically valid, that's great. So here I've broken up the bike ride into the first part, the second part, and the total. So we know first part is 30 kilometers, then 10 kilometers, so a total of 40 kilometers, and I've filled in the rates that we know. So let's talk about the times that we know. Here, if I just do this distance divided by this rate, that'll give me 3 1/3 hours. That's for the first part. And then the total time I know must be 4 hours, because 40 kilometers divided by 10 kilometers per hour. Well, that leaves us with 2/3 of an hour for the second part, because altogether it must add up to be 4 hours total. What we want to find is the rate for the second part. So you'll notice that we could also do the distance divided by the time. So the second part is also 10 divided by x, 10 divided by rate is the time. And then I've just got a proportion that I can solve. And if I cross multiply and solve that out, I'll get x equals 15 kilometers per hour. And you can check that back into your original problem to make sure that it works. All right, this is kind of similar to some problems that we did in problem set 7. So she's going to prepare C cups, and then she sold all but 13 of them. So she sells C minus 13. So if I'm thinking of the money that she brings in, she sells them for $1.50. So it's going to be $1.50 times the number sold minus 50 cents times the number prepared. So then if I multiply this all out and simplify, I can see that she must have prepared 40 cups.